Hey guys, I just wanted to go through a walkthrough for 1.3.2 whole notes, the annotations, the sort of handwritten part of this assignment. Things I have open are, hold on, let me move this because every time I move the mouse it touches that sticky note. There we go. So I've got this open, the whole notations assignment in Canvas. It says part 1, upload a photo here of your whole notes from the instructions, and the whole notes should look kind of like in this picture here, these things that I've written out in maroon. I've done an example for that right here, so if you don't want to follow the exact precise directions and lose some points by following my exact precise directions here, go back and look at those instead, and then do it on your own. If you do follow these directions, it's been so long, I just want to get you guys, make sure you guys have the grade for this. So if I've sent you this video, if you'd like to, this will get you a B in this on this assignment, and that's what we need to do. That's what we need to do. All right, so whole notes PDF is what I've opened right here. It's I think I've called it IED CAD Basics. It comes up in that window like that, but it's called wholenotes.pdf. And what the assignment said, went through this. This is my lecture. Please watch my lecture videos if you haven't already. It goes through how the numbers in this image right here, what they mean regarding the shape of a hole, and how to make it look like this notation on the right side. And here's another example, and I go through this again in the lecture videos. Please go back and take a look at those. Here's some more examples of what hole notations will look like. The first row is always going to have the diameter of the hole. That's the main part of the hole, the part that goes all the way down. And it's going to have a depth of the hole. And some of them, you can see they have the depth symbol, and they have a number, and that says it goes in like 2 inches, or it goes down 2.25 inches. And there's some that say THRU. That just means it goes all the way through that material to the other side. Okay? So the assignment is to make whole notes in CAD. Write a whole note for the following. I'm going to use the mouse. It might not be the best, but like here's A. This is what you're going to do. You're going to look at this right here. And let's see. First thing you're going to do, your first row is going to always have diameter in it. You're going to use the diameter symbol, which is the O with a slash through it. You're going to look for the diameter of this thing. So the diameter is of the entire hole is the part that's at the bottom. It goes across from this left side to the right side. It doesn't go across the top with that special feature. It goes across the bottom part. So right here, 0.50 inches. So I'm going to just put, you can put 0 in front of it. Man, this is hard to write with. 0.50. Yeah, it's hard to write with a mouse. There we go. I don't know if I'm going to be able to write with this mouse. I'm going to have to get the Elmo working after all. 0.50. I didn't put the 0 in front of it, and that's okay. Sometimes you don't see that. It's all right. 0.50. All right, so now I need the depth, and normally I do the depth symbol next, but let me double check what the depth is. The depth is the depth of the entire hole, so it's shown on the left in this diagram. It goes from the top of the hole down to the bottom, not counting that little tip at the bottom, which is like if you're actually drilling this hole with a drill, the drill bit has a tiny little wedge at the tip of it. That's its little conical shape. And so that little tip at the bottom, that's not part of the hole because it doesn't have the same diameter. It doesn't go all the way like that. So this is the depth, and it's located, in this case, right here. It says all. That means it goes all the way through. That means instead of the depth symbol, I'm going to write the word through, THRU. My handwriting is 10 times worse. On here, okay. So all holes, all notations will have that. They'll have that information. You'll need to tell the person who's making this product, or the person who needs to figure out what size screws to put in the project, or bolts, or what kind of fasteners to use. You're gonna have to say, hey, this hole is 0.5 inches across, and it goes all the way through the part. Notice I didn't put units right here. I did not put inches right here. Usually when you've got a diagram, let's see if this one has it. No, it doesn't. Usually when you have a diagram, it will have somewhere on that diagram, either in the little title bar down at the bottom, the title block, or it'll have just written somewhere, unless otherwise noted, all measurements are in it'll give you inches, millimeters, whatever that unit's going to be. So you don't usually put units in your whole notes. And again, this is just how we're doing it in this class. There will be, like, if you go on, you're actually going to be an engineer. You're actually going to design things with people. You're actually going to work with, you know, producing this sort of stuff. You might find that your company wants you to put inches in there. And if that's the case, by that time in your career, you should be able to make the switch pretty effortlessly. All right. So the next thing to look at is, does this have anything else going on besides, look, I'm going to like X through this. You don't need this guy down here. That's in every single one of these holes because theoretically it's being drilled by some sort of drill bit. The next thing to say is, does this have any special features? And this one does. It's got this guy right here, and here's all the information that goes with it. This guy is called a countersink. And you can tell it's a countersink because if you look at the shape it makes, it's kind of a V. That's a countersink. All right, I'm going to get rid of that. It's in the way. So the first thing you need to do is you need to, I'm also going to get rid of this. Oh no, don't take the ruler away, thank you. I'm going to get rid of this, it's in the way as well, sorry. First thing you're going to look at is, what kind of feature is this? Is it a countersink? Is it that V shape? Is it a counterbore, which is sort of the field goal shape, or the upside down staple? This guy has that point at the bottom. It looks like it's really triangly on the ends and stuff, so it's going to be a countersink. You're going to start your second line with the countersink symbol. And then countersinks and counterbores each will have a unique diameter that is wider than the original diameter because you're going to have that feature sticking out a bit compared to the original hole diameter. So if you look on the diagram, the diameter here across the top of the hole, that is the widest diameter on that countersink, and it's 1.00. So 1 point, I feel like I'm using an Etch-a-Sketch. It's worse. I feel like I could do better with an Etch-a-Sketch. And since it's a counterbore, we don't have a depth. What we do have is this angle in the center of it right here. That's where it's located. That's where the information is. So the next thing you'd write is an X, and then you'd write the 82 degrees. And I've run out of space on the side here. Oh no, I haven't. I can write over there. 82 degrees. And that'd be your whole note for this first one. Okay. Gonna get a new screen cap of this guy here. How likely am I to recommend Windows Photo apps? No, thank you. So yeah, B is going to be this picture right here of this hole. This hole here is what's called a simple hole because it doesn't have anything extra at the top. It doesn't have either of these special features. So let me take a screenshot. A new screenshot of B. Leave some extra space on the side to fill it in. All right. First row always starts with diameter. And we're going to look for the diameter. The diameter, there's only 3 things measured right here. There's this guy up and down, the guy across down here, and then there's this sort of angle here. Remember what I said about that angle here at the bottom? Don't worry about it. That's just basically saying, hey, we know it's going to be drilled with a drill bit. We know that it's going to have this little conical tip at the end of it. Don't worry about that. At least not at this level. All right, we got going across is the diameter, so we're going to go across right here. That is the 0.5 inches, so 0.5 or 0.50. At some point we'll have a discussion about whether 0.5 is okay, whether 0.50 is necessary. How many sig figs do you need? How much detail do you have to go into? I feel like I should have had this conversation sooner, but it's only coming up right now because I'm thinking about it. Now I've got to figure out the depth. So the depth again is up and down from the top to the bottom. It's right here, 2.5 inches. So I need, since it's got a number, I need my depth symbol. That's a line across and an arrow that points straight down. That's a really bad looking one. I can't tell what it even is. There we go. Straight down and down and down. Trying to connect it. If I can get the Elmo working over here, I will redo this video. It goes down 2.5 inches. 2.5. There we go. Second line. Is there a special feature here at the top of it? Nope. Nothing. Don't have to worry about it. That's the whole note for B. That's all you gotta do. All right. If you've been following along, pause right here and see if you can figure out what to do with whole note for C. Alright, if you're back with us, I'm just taking a picture of this one and getting ready to annotate. Okay, first row is always diameter. That's where you start. That's a bad... Let's try it again. Alright, my diameter is across, and in all of these so far, that's been this one right here, from this wall to this wall. There we go, 0.25. I need a depth, because every hole only goes down, it has a certain distance it goes down. Might not have that going like that. About like that. There we go. All right. The depth, that's all the way from the top to the bottom, and again, ignoring this little tip at the bottom, ignoring that piece. So that is 1.75 inches. 1 and 70. It's supposed to be a 1. This is the most frustrating thing, I think. I think this video is going to be longer than 5 minutes. 0.70. I try to cross my 7s like that because I feel like if I don't, sometimes my 7s and my 1s, when I'm hastily writing it by hand, they don't look the same. Or they look the same, they look close enough you can't tell what they are. Alright, first row has the diameter of the main part and the depth of the hole, and the second row is going to have any extra information from right here. And look, we've got a different shape than last time. We have this shape that goes down and over. It's got these 2 right angles. That's because it's just a different, another cylinder carved out at the top. So we're going to make that symbol here for counterbore. And we're going to give it the diameter and the depth. The diameter of the counterbore should be more than the diameter of the hole, so 0.75. Oh, I forgot I didn't put 0 in front. I'm trying to be consistent. 75. I look like I'm a second grader trying to write. My second grader wrote better than this. Okay, depth is, alright, it's 0.75 because that's, again, diameter. It goes across. There it is. The depth of just that feature is 0.375. It's going to be a smaller number than the depth of the whole thing. So 0.375. Man, I can't write. Okay. If you followed that, that is the exact thing that I need you to do for this assignment. That is all of it given to you to do. All right? Again, if you haven't done this yet and you needed this walkthrough, that's fine. We'll get you the B or whatever on this assignment, and yeah, I'll see y'all later. Have a great afternoon or morning or evening, whatever time of day it is. Y'all stay safe and healthy. And yeah.